welcome guys to another little video. Now today we finally made it to what we have here. Now we have our little turrets and we can place more turrets, but more importantly I've developed power requirements for the turrets. Now I haven't hooked it into a graphic or anything like that because, well, everyone has their own little way of doing stuff, and when it comes to model, you might want to put it in the model itself. Like this little green circle you might want to put in the red if it's out of power, or you might want to do some kind of effect where it shoots like a little lightning bolt on it like mini games have. You never know. But for the most part, I have it set up where you can shoot. It requires power in order to. If we have no power, then it just doesn't work. And we are pretty dynamic on the building itself. You know, I can't place, stuff on top of it. You have to have a space. Now, I don't have any visual markers yet, but that's not very hard to do. We've done it in the past. And we might, do something further down the road that way. But for the most part, I just didn't want it to, overlap and be stupid looking, right? Now, each turret requires X amount of power a shot, and I've coded it in such a way where it's not so bad. I mean, even with recording, I'm still hitting 60 frames, so I'm not lagging out. And these are physical bullets as well. They are actually being shot out. Spears, matter of fact, I believe. Which we can make that even better by using something in Blender as a model. And then just use normals and stuff like that to smooth it out. Or use my favorite thing and just use particles. But, particles are expensive as themselves. Now, I haven't put particle effects yet on the tips and stuff, just because, it's nothing to code in. I mean, and plus, I don't have any particles, and I didn't want to plug up my project with, throw a particle system in there or download one. So, it's just one of those things. It's a little preference thing. But the function is so easily, I could show you how. But in today's episode, I'm going to basically show you guys how to get these things shooting. Just the tower script itself. Because we also have to go over the power management. And this is the second wave of this. The second iteration of this version of it. So I'm going to have to go over all the scripts that I had before and show you all the changes, so we can integrate power, buying, and all that stuff in there, because we actually have an upgrade button, okay, which is kind of blank right now, which I haven't wrote the logic for it yet, but it's there. You can sell turrets, and we have our research and our shopping, which I'm still working on this UI part, because here's the thing. For every component we add into the UI, it's another draw. So I'm trying to keep the draws down, because we actually use physical bullets. Where if I had too many stuff in the UI, it might slow our game down. But I haven't seen too many issues. So we can buy steel, things like that. I might do some kind of node where you can build something on a part of the level to get steel or iron or anything like that, which wouldn't be that hard because the power system is pretty much that way. But without further ado and stuff, let's get into the code for the tower itself to get this thing shooting. But yeah, because we're gonna have to go over a couple of scripts easy. So let's get a cracking. Now let's go into our good old Unity personal build, and why are you blank at being stupid? Unity? There you go. I knew you could do it. Alright. So here's our nice little Unity project here. And I'm still with the canvas and things. And I'm still in debug mode. Okay. So we've got a pool lookup and some other stuff. You're going to see some stuff that you haven't seen before. Now, in this project, this image right here, I'm trying to eliminate, and eliminate this one too, is because of draws. Okay? And mostly it's to get, I don't want to go into here and have an image for every single one of these. Okay? So what I'm doing is I'm going to be constructing a image 2D that's right here. And what this image is going to do is it's just going to be set. I'm going to tell it where the anchor and all that good stuff. So in all our panels, we don't have to have this image component ever. It automatically just is there. And each one of these image components is a draw. So when the panel parents something and does a redraw, it's not as hard. Now you might be like, oh, this sounds unnecessary and things. It might be, but I don't see why I've got to have an image here, image here, image here. You know, some of this stuff just doesn't seem, you know, just flat out useful. Now, actually, in another sense, I'm thinking, and what I'm really thinking too, is, you know how we've got all these right here? I'm thinking about making like a dead zone component. Because in Unity, if this isn't in the screen, like our screen space right here, like let's say, like this right here, okay? If you look here, we've got 8K vertices, right? But if we go all the way down through here or so, it goes down until we hit, where'd it go? Lost my cube. Really? But that's kind of depressing, right? Lost my cube. Gosh dang it. How much further away is the cube? This game object? Wait, the cube's not here? At all? Where'd it go? Oh, there's the cube, right? No? Quad? Spear? That makes no sense, huh? Oh, there it is. Oh, it's called a plant. No wonder I couldn't find it, durr. But, like I said, we've got 8, almost 9K, you would say. I'm just going to round it off 9. But if I go out here, it goes almost back straight down to 8K. So there's like 8K worth of vertices. When this thing is in the rendering zone. So it's the same thing with these buttons, okay? Is if I made like a dead zone thing, like let's say empty right here. Wait, why'd it go there? Empty. This empty game object and named it like dead zone. Okay? And then instead of like instantiating this or destroying this, we could possibly just go, hey, this build panel right here is the only one that's going to be here. So I'm going to parent this into the dead zone, this into the dead zone, this into the dead zone, and there you go. Most of it is all going to be in the dead zone. So does this help us in any way? Let's just delete this. 5K, 5 passes. We just delete this. It doesn't do anything for us. So let's see what it's like when all of them's there. 4K, 4 passes. No, that doesn't. Wait, 11 batches? 11 batches. Delete this one? Delete this one? Doesn't seem like it affects it. Oh, that's kind of nice. So in the visual cue, we don't really have anything in here. Oh, that's kind of nice. Man, I'm not even going to worry about the panels too much then, if that's the case. Heck no! Oh, that's a crash. Whoop. Whoopsie! Poopsie! Yep. That's a bad... No. Oh, I forgot all about it. I deleted something in there and then hit a button. So, Unity doesn't like it because it's not there. That's fine. That's fine. So, let's go over a method instead, since it wants to be that way anyway. So, let's go into our nice little thingababa. Alright, there we go. Alright, this isn't actually the one I want anyway. Oh. Okay. So, this isn't what I want anyway. Alright, so, good old Virtual Studio. Let's pop this open. Like a birthday cake. Love cake. Alright. So, let's go into... What's the first thing we need to go into? Modes, no. Messenger, no. Game behavior, no. Oh! We were going to do turns, right? Right. So, where is the turn script? Why? Really? Where is it? I know I have it. That's kind of weird. Okay. Oh, this is completely the wrong Virtual Studio thing. Okay. That makes sense. Alright. So this is the wrong copy of Virtual Studio. Kind of sucks that I just can't like rebuild the library and stuff. Alright. So let's go into here. We don't want to go into the game. We don't want to go into that one. Alright. So in our tower script, some of this will look familiar, some of it will not. If Okay, we got to go over this script and go to declaration. All right, so build object, save to file, cost. We have it returned to null, and this error message isn't important. It just says, hey, don't do this. Okay, and then we have a save component, which I don't think you guys have this yet, but you can like write this down this way and then just exit it out. Okay, because we will be using it, I know for sure. Okay, and this is one of the things I guarantee we're going to be using as well, because we call this up. Get enemy, and it must be public and virtual. Okay, not a big deal. Very, very minimalistic script. Okay, so let's get out of this script because we don't need it no more. Alright, now you'll have all these fields. This is a head, a helper, your hard points where you shoot out, your turn speed, fire time, and fire time. Yes, we do need 2 because this is going to be unique to this tower. We could do some other stuff, but you know, with constants into another script like get field or something, but it's not exactly ideal to do. Just put it in there and there you go, because we're going to be using that as a countdown timer and we need to know what it is. Error amount 0.5. If you put this too low, your turret will not shoot because it's based on an angle for the error amount. Transform our target object and target values. This must be a quaternion. If you try to put it in Euler angles and stuff like that, it messes up and goes all gook-eyed with you. Okay? Doesn't stay very cool. Now, this is our bullet field right here. Our bullet. Okay? And this is something that I need to go over with you guys because I was sitting there trying to figure out why my bullets weren't working and things, and it's because of asset bundles. Okay, now here's a tip that may not be to you if you're not using it, but if you are, you have to do it this way. Okay, in your project, when you go to your prefabs, okay, let's say this is your bullet right here. You cannot put this in like an asset bundle like this and compile it into a bundle, okay? If you want to reference this in your turn, like you go in here and you put your bullet prefab in here, if the bullet is part of an asset bundle like this, when you instantiate this, this will become missing, okay? This will go missing game object every single time. Drove me bat crazy trying to figure out why it was missing, okay? And that's exactly why. If you reference something inside of here and it's part of a bundle and not this game object that you're instantiating inside the bundle, like referencing itself, like a prefab, like you would like your bullet, it will freaking go missing and mess everything up. Took me forever to figure that out. I was like, what is going on here? Oh, I was mad. But if you take your bullet out of here and, you know, out of the asset bundle and put none, like it's not part of the asset bundle, it will work perfectly fine. Now, the reason why I just didn't do a string to this is because strings are expensive to compare with. Okay, strings kind of are a no-no. Don't use strings for a lookup for your thing. use the game object itself. Very quick. And that's going to be part of the pooling system. Okay? And we got enemy layers here, for layers. And your range, it's pretty common basic stuff. Now, for your turn, if you're like this and everything, here's the thing about the turn. Alright? You're going to have your turn, and we're going to have a helper, okay? Your main game object and then the thing that you're turning, they both have to be in the same level of thing. If you put your helper below the thing you're turning, it'll go all stupid on you and everything else. It won't act right, okay? So if you put your main game object, like your whole thing, you've got a head here that you're, flopping around, turning. Put your head helper in the same level, okay? What I mean by the same level is, okay, you've got an empty. Take this spear, okay? That's the parent. Well, guess what? I need a head, right? And we're going to put a cube under it, right? In the same level, okay, I want another thing, another cube. And this cube will be our helper, okay? It'll work perfectly fine there, okay? Because this is being pointed directly at it with no interpolation, alright? So whatever this one, the helper, goes to, the cube will lerp to that, okay? So we're going to interpolate this cube right here based on this stuff here. If you parent this right here, this will point here, but it'll be based on this parent's coordinate system. So it'll go all dumb on you. Where this one is in the same coordinate system. This is the parent, this is something, this is something. Alright? It'll all work out beautiful if you keep that structure. Now, it might be hard to see it because I realize it is on a, YouTube video things, but hopefully that helps you. Alright? So let's get back to the code. Alrighty. We got our spawn system, which I call ammo, because that's basically what it's going to give us. Okay? Now, if you don't have this system, just write it down and exit it like that. Okay? Because this is part of a pooling system. We have it return the pool instead of that. So, once it returns the pool, we just keep asking for game objects, right? We use the bullet as our lookup to return the pool. So we go directly to the pooling system. No stupid lookup every single time I want to shoot a bullet. Alright? We're just gaining a reference. Okay? Because this is a mono behavior. And, that's the cool thing about it. Now we have battery. This is the max amount of power that it can hold. Okay? This is our current power, which I called cap, and the need amount. The amount every single time we fire that we need. Now you can adjust these accordingly or whatnot, but you need 3 floats. Or we can do, you can do like constant things in another class and things like that, but we might do that later for this because, just make 4 constants and this be like something universal for the maximum amount of battery. That way we can lower our overall floats in memory. Now, in the start, we go ammo equals pool lookup dot pool dot get pooler, and we use the bullet as our reference. Okay, so when it looks it up, it goes, hey, this is the pooler for this game object. give me it, okay? Our capacity equals battery. This gives us our our energy amount from the beginning, or maximum, because it doesn't make sense to not have any electricity when it first starts off. We just built it, right? Now we have, if target does not equal null, we go targeting, which we'll look at. Targeting is right here. Target values, which is a float up top, well, a quaternion. It's a quaternion. And we do this dot tower full range 3D. We pass it the helper and the target. Okay, this returns a quaternion. All right, and it's just a normal void. So every single time we pass this, it calculates stuff. Okay, and we do a head local rotation equals quaternion dot slurp head transform dot local rotation target values turn speed times by time dot delta time to make it frame rate dependent. So it goes X amount of, it rotates, X amount per frame at a set rate speed. Okay, and that's the targeting. If fire time, the underscored version, is greater than or equals 0, we do a decrease. We just decrease it based on time dot delta time. Okay. And then in our next line, we'll go if fire time, which is the underscored version, is less than or equal to 0, and head helper dot able to fire head, then the helper, then air amount equals true, then we execute this stuff. Okay. Now it's this right here. This is actually a extension. Okay. Now if we look at this and go into the extension, does it show it? Yes, it does. We can look and see this is a public static able to fire, which is, I call this in a static class extension methods. Okay, able to fire, and I put it under this dot transform test and transform myself, transform target, and then air amount. We do float angle. It's just an angle calculation based on target forward and myself dot forward. And if it's within the, the space. Why am I doing target dot forward? I don't think that's right. I don't think I do target dot forward. We'll figure that out. If angle is less than, aim skill, we return true, else false. Okay? And that is our calculation for this bool right here. This returns true or false. If cap, which is our power that we have, is greater than 0, we set the fire time. See, we've been decreasing it. Now we just flat out equal our fire time, which is our total time. The amount that we want to fix it back, right? Capacity minus equals need. And now we have our bullets here. Now, if you don't have, like I said, you can always exit it out like this, okay? And exit this thing for right now. But this will be part of the system. We make us a game object variable. And then we do emma.getPooled, and we go into true because it's part of the pooling system, and we want it to grow if there's no available bullets. If fire temp is not equal null, we go fire next and return. Now fire next is very easy. This is where you can put your particle system as well. Okay, fire next, we pass it a game object. Okay, the reason why we do this is because the game object that we get out of the pool, it's disabled and we don't have a position for it yet, right? It could be way off in outer space or whatever. So we're going to do a temporary integer fire index random.range. And if you got system in here, like this, using system, it's got a version of random.range, and it'll throw an error this way. And to fix this, all you got to do is Unity engine dot random dot range. See? But you shouldn't have system in it because it's not necessary unless you're doing like some string stuff. But if you're wondering why you got that error and stuff, that's why right there. Okay? It's not anything, really wrong. So we're going to go 0 to turret point dot length. Okay? Because we want a random between the min and the max. Okay? So if there's only one, turret hard point, then it goes to it. And it doesn't go out of range. And throw an error. Okay? Fire.transform.position equals turret based on this index transform.position, and fire rotation is also part of the rotation. And then after it's moved and everything, we set it to active. And then the bullet just flies off because it's got its own script to make it move and all that good stuff. Okay? So if your bullets aren't moving, it's because you didn't attach a script. It has nothing to do with the turret. Okay? If you wanted a particle system in here, you would probably have an array, okay? And then you would use this fire index in it. And then you would just do particle, particle dot play, and that's what you would do. Okay, and you do this based on particle, and then you'd have an array, and then you do a fire index, and then play. Okay, and I think it's a function like that, or it might just be, one of those things. But you do your particle variable, like that, and just hit play. Which, in all honesty, there we go. Particle system, and it's an array. Fire effects. Boom, and we'll just do it like this. Let's just code it in there, I don't care. We'll go fire effects, dot play, boom. And we will do this based on this And and I need this to be at least a serializable field. Boom, done. Coded. Told you, it was very easy to get this in here because this will only play once. Okay, so we have our effects here. Well, guess what? If this doesn't work, if we don't have enough power and stuff, it goes to this else statement here. Okay, and make sure you got these brackets exactly this way, because if you don't, it's not going to do the else, and if you try to do it if else, it's going to mess up on you as well. Okay, because it's an else statement based on the capacity here. It's like asking a question, yes or no. Okay, this is yes, this is no. We're going to do cap equals power management dot get, and then we're passing battery. Battery is how much maximum it can do. And we do this kind of function here because our power management thing, our current power is being updated every single time we take power from it. So to keep the UI system from doing rebuilds every single 0.3 seconds or every 0.1 seconds, we give it a capacity in our turret so that way it's not as frequent, because the more we don't want to call this every single frame get power and then have it do all that math calculation, because it could slow down our program. So we do a capacity like thing, so it only gets like 5, 10, or X amount. So that way we can have it just do the calculation. Hey, we're deducting something like ammo in a gun for your first person shooter. That's all we're doing. And that's it. That's it for that. And the enable, we have an enable function, game behavior dot add to loop this. On destroy, we remove this. Our cost, get cost, which is just a variable. We've seen that. And then here is an overlap spear. Okay, we have colliders, our layer mask, and our range. Okay, now all this right here must be public and things. Okay, we're doing just a simple overlap spear at this transformed position, range, enemy layers. Okay, but you need this if statement here. Okay, if the target is null, it'll never execute this. Okay, well, it'll if it's not null, if the target's null, it will let you do the spear cast. Okay, but if we have a target, we don't want to do a spear cast and change our target. Okay, that would just be dumb, right? Because our target's not dead yet, or anything else. And we just do collider.length, and bam. It's real simple. I always do 0 right here. If it's greater than 0, we just grab 0. And it's a random target. It doesn't really matter, I guess. We could probably do a random.range here like we did in the here. Well, pick a target. Doesn't matter. Just pick one. And once it has a target, it never executes this again. Now, you're probably thinking, why are we doing this game behavior.add to loop? It's because add to loop is actually a function in here which does things. Okay, add to loop is a static list of build objects. Okay, Now, the reason why we do it this way is because we're looping. We're adding this to the physics.loop, and every single fixed update, we're going through that list and calling getEnemy one time. So if I have 15 turrets in there, we're calling it one time in each physics loop update. So we're going through the index one at a time, each physics loop, okay, which is not dependent on your frame rate. Okay, if you got 0 frames, it's still doing this in the background. Okay, physics update, fixed update works completely different. Unless your processor is like smashed like 100%, this will not be affected by your frame rate. Okay, and it's a fixed frame rate too. It can only, I think it's like 53 or something like that frames every, and I'll explain why we do it this way. It's because we don't need a spear cast every single frame by every single turn. That would be, that's the exact reason why this exists. In our tower thing, doing a spear cast every single frame in a fixed update for our turn would be very expensive. Okay, it would be very expensive to have a fixed update to do an overlap spear every single fixed update for every single tower that we have. Let's say we have 60 towers. That's 60 fixed updates. That's crazy amounts, right? But you're thinking, well, we have an update this way. Update, there's no getting around this one. Okay, I'm not gonna lie, there's no way of getting around this one to space it out. No really great way. I'm sure I could find a way to get enough updates to have this work correctly, but come on, it's a hack, okay? And I don't want to put some hackish code in here just for an update tick. And I've seen people do in start method do a invoke repeating and things. Well, guess what? That invoke statement, coroutines, and everything else are still in the main thread. Okay, it's pretty much no difference than to have this update here. The only thing about update that's kind of nice based on is update will run as fast as it can. And let me explain it, because this is something that kind of sucked when I was doing timers for powers and stuff. Okay, we'll go into here. Oh crap, I might have a problem. Is my particle effect thing. It's not going to like it because I don't have a particle system. Okay, so in our game here. Alright, you see this little 11 FPS? That's how many frames I'm getting. Okay, frames per second. That's how many updates that it's calling. Okay, everybody thinks that the update method is going to be called 60 frames or so. No. You can actually have more updates happening because it's per frame. It actually is like exactly like the thing says here. Like, let's say we go into our profiler here. Okay, you'll see 40, 60. Well, guess what? You see this part right here? 5 milliseconds? This is on the processor itself. Okay, we can actually get 200 updates per frame right now here. Okay, this frame rate thing, I'm getting 90 updates. 90 updates. You know, every 10 milliseconds. That's one reason why fixed update kind of works better for some things, because it is a fixed duration. Alright? And that's one of the reasons why some people use invoke repeating and things like that, is to get away from these flexible frame rates like this. Now, I'm not going to sit there and say that it's not a good way of, you know, getting around and things, but I don't really care about it having 90 some right now. But if you're really hurting for like CPU and stuff when you're stretching it out to as many towers as you possibly can, then you may have to do something like that. Instead of having update, call it like on update, and then do an invoke repeating every 0.1 seconds. Call the method up, and it'll give you like an update. It'll be just as fast, but it will limit it a lot, if you know what I mean. It's, you could do the float value just high enough where it'll keep it running smooth. You know, it's kind of hard to explain. Words are hard. Words are very difficult. But yeah, that should do it for the turns. And well, actually, it won't do it for the turns because we need a bullet. Okay, so let's go and give you guys a bullet, which if you looked at the last version of the kit, you should recognize this code because I pulled it right from it, because that's all it does. On enable, we invoke fix my bullet after die time, which, you know, is 4 seconds. If 4 seconds, if it doesn't hit somebody within this duration, we just disable it. That way it doesn't stay like permanently enabled the whole time. Okay, we got a rigid body, we need a thing for it, and damage, speed, all the basic stuff, tags. Okay, and we just do an update.translate based on speed, time.delta time. I do this in update, which I could probably do this in fixed, and it would probably do better. Doesn't matter. Enter, colliders, compare tag, send damage, you know, and if it hits something, regardless, we do fix damage, fix my bullet. Pretty simple. You know, on collision, on trigger enter. Now, if you're doing on trigger enter or thing, make sure you do a collider and the appropriate thing. If you don't know, go look it up on the API. On trigger enter, and it will show you a collider other. On collision enter, you're detecting other stuff. So just make sure you fill this variable, right, this overload parameter with the appropriate thing. Because if you get this wrong right here, it'll act all stupid for you. Okay? So that's pretty much it. I mean, it's not a big deal. And there's your bullet. And I think you guys should be good. You know, like I said, if there's one thing, you know, if you don't have the pooler, just replace it with instantiate for now. But if you have if you go look at the older version of this kit, you will find the spawn system. I just took the spawn system out and, you know, did that. It's not that hard to put a pooling system in. But yeah, thanks for watching, guys, and take care.